In this lesson, we're going to be looking at arithmetic sequences. It's section 8.2. Geometric sequences will be in 8.3. So an arithmetic sequence is a sequence whose consecutive terms have a common difference d. So a common difference of the sequence could look something like this. It's saying that the second term minus the first term is equal to some value d. Likewise, the third term minus the previous term, or the second term, is equal to that same value d. The fourth term minus the term before it, or the third term, is equal to that same d value, so forth and so on. And number one, let's determine whether the following sequences are arithmetic. If so, we're going to determine the common difference called d. All right, so I'm looking at example A. I'm looking at this sequence right here. And I can see that the terms of this sequence are increasing in value. Do they always increase by the same amount? Well, what's the difference between these two terms where I take a sub 2 and subtract a sub 1? 1 minus negative 4 is 5. If I look at the third term, we call that a subscript 3 minus a subscript 2. 6 minus 1 is also 5. So forth and so on. 11 minus 6 is 5. And 16 minus 11 is also 5. So yes, this sequence is arithmetic, and the common difference is 5. All right. 5 minus 3 is 2. The difference between term 3 and term 2 is 4. You can stop right there. There is no common difference because this is not an arithmetic sequence. So this is arithmetic, and this is not. Okay, example 2. Write the first 6 terms of the arithmetic sequence. All right, the first 6 terms, well, the first term is already 300, and the common difference is positive 50. So I'm going to leave all of this space, and I'm going to come down here, and I'm going to report what the answer would be. So if I'm writing the first 6 terms, the first term is 300, as indicated by that notation, comma, and I just keep adding 50s. And I'll stop when I get to 6 terms. That's going to be the answer to this problem. Easy enough. So what's all this space for? Well, there's another objective with this space. I'm going to use this space to show work that would give us this answer right here, because in doing so, we're going to develop a formula that we're going to be using later. All right, we're asked to find the first 6 terms. So term 1, a subscript 1 is 300. All right, next we need A2, the second term. Well, the second term is going to be the first term plus 50. And I'm going to put a 1 here in front, plus 1 times 50, because I'm only adding 150 to the 300. You do the work and you're going to get 350. So what are we doing when we get the third term? Well, we can go back to the first term, but now this time we're going to add 2 50s. And now we'll get the 400. Like I said, we already have all the answers down here, but this is the work that's showing it. There's patterns that are going to be developing, and we want to look at those patterns to help us understand a formula that we're going to be using in a minute. So the fourth term can be found by going back to the first term and adding 3 50s. And I'm going to do this until I get to the 6th term. Okay, so we now have all 6 terms, which we got just by, eyeballing it and inspecting it. Okay, so what should we be seeing up here in patterns? Well, what we can notice is that to get the second term, I'm only adding 150 to the first term. To get the third term, notice that this 3 and this 2 compare by 1 less. 2 is 1 less than 3. To get the fourth term, you add 3 50s to the first term, so 3 is 1 less than 4. 4 is 1 less than 5, and 5 is 1 less than 6. So if for some reason I wanted to find the 38th term, I would know that I would be adding 37 50s. So that's good to know that pattern. So coming down here and looking at one of the formulas that we're going to be using, okay, let's see if we can see the structure of what we just did in this formula. This is saying to calculate some specific term in the sequence called n, and n could be the 15th term or whatever. To get the 15th term of an arithmetic sequence, we start with the first term and we add, and you could put 15 in here. If n is 15, then we're going to add 14, 15 minus 1, 14 common differences to that first term. So hopefully you kind of see the structure in what we did, okay, represented in this formula. And by the way, go ahead and cross off this formula because we're not going to be using that one. We've got enough on our plate to deal with just at least this formula. Okay, let's go back to part B. Same thing, the first term is 200, but notice that we're adding negative 60 to consecutive terms, to previous terms to get the new term. So let's see if we can kind of handle this the same way down here. Let's get the answer first, then go back and look for patterns. So my first term is going to be 200 in my answer of 6 terms, but then I'm going to add negative 60. So that means I'm reducing this number to 140. So subtract a 60 here, 80, subtract a 60, get 20, subtract 60, get negative 40, and one more time gives us negative 100. So this is an arithmetic sequence containing 6 terms where the common difference is negative 60. So let's go back up here and develop a pattern that again makes us understand, helps us understand this formula that we have down here, okay? So the first term is 200. The second term is going to be the first term plus 1 times negative 60. You do all that on the calculator and you get 140. The third term can be found by taking the first term and adding 2 negative 60s. So if you do all that work, we should get 80. So it's confirming with what we have down here. And then all the way down to the 6th term. Noticing that now I'm going to add 3 being 1 less than the 4th term, negative 60s. And lastly, 5, which compares to 1 less than 6. So if 6 is our n, then 5 is n minus 1. Now, would I do all this work to answer this question? No, but like I said, my ulterior motive was to make sure that we understood this formula down here. Certainly if I'm doing this problem and it's a multiple choice problem or something where I didn't have to show my work, you know, I would just go right to the calculator and generate these 6 terms of that sequence. Let's deal with some fractions here. Same thing, I'm going to come down here and report the answer and then confirm it with all the work. So the first term, as indicated by that notation, is 3/4. I'm going to add negative 1/4, so that means subtract a 4th. That makes this 2/4. 1/4, keep subtracting 1/4. 1/4 minus 1/4 is 0. Subtract a 1/4 from there. Now we're in the negative numbers. Subtract another 4th, that's negative 2/4. You might be thinking, okay, should I reduce these fractions? Yeah, you can. That would reduce to a half. This would reduce to negative 1/2. That's fine, and that's probably the way it's going to be requested on a homework assignment. However, the reason I like to leave it like this, unsimplified, these 2 fractions, is because you can really see the pattern in how these numerators are getting to be 1 less each time. I think if you simplify, you just kind of lose the effect of the pattern. Okay, but just make sure that on the homework that you go ahead and reduce because they probably want the answers reduced. Okay, let's go back up here and do all the work that supports our answer we got down here. So here's the first term. The second term is found by taking the first term and adding 1 times negative 1/4. So that would be 2/4, etc. First term plus 1 less than 3, or 3 minus 1, or simply 2, negative 1/4. So negative 2/4 added to 3/4 is 1/4. So 3/4, 2/4, 1/4. Again, if you want to simplify that to a half, that's fine. And like I said, you probably should on the homework. Okay, these two numbers compare. I want the fourth term, so that means add 3, 1 less, -1/4. So now we're down to 0. And again, that could be -1/2. Now, again, do we have to do all this work? No. I mean, if you understand that you're subtracting 1/4, 5 times to get 6 terms, then that's great. Just go right to this. Just wanted to make sure we understood what this formula was saying right here to us. So, for example, back up here in part A, what if you wanted to find the 103rd term of this sequence? Well, I'm not going to sit here and write out 103 terms. If I want the 103rd term, I'm going to realize, hey, this formula will help me get the 103rd term, where n is 103 here, and if n is 103 here and subtract 1, this becomes 102. We would have to know what the first term is in the common difference to use this formula, but we will know, or we'll be able to find it out. So this formula is great when we have a sequence that we're wanting a term that's far into the sequence. All right, D and E. Similar yet different. D and E are both what we call recursion formulas, and we've seen that term before. Recursive formulas, recursion formulas. Sometimes it's called recursion formulas. And as a reminder, a recursive formula is not what we call an explicit formula, where we can get right to the specific term of the sequence. Recursion formulas mean we have to know a previous term before we can find the next term. So let's just kind of study what we have here. This says a subscript n is equal to a subscript n minus 1 minus 30. So if I want to know the 14th term of this sequence, then if n is 14 here, it's also 14 here, then I would have to know a subscript 13. I would have to know the 13th term. So we can identify recursion formulas by this little subscript notation right here. Okay, but I can see in this problem that I'm going to take the previous term and subtract 30. So that's the important part of this. This is actually what we call the common difference. We're always subtracting 30. So let's let D be -30. So again, going back up to the instructions, we're supposed to write the first 6 terms of this arithmetic sequence. Okay, the first 6 terms, well, I know the first term, it's 100. To get the second term, I'm going to use this formula. If n is 2, then n is 2 here. This will simplify to a subscript 1, and then I've got the -30. I'm going to work across. I can get a subscript 2 because I know the previous term is 100. So now replacing a1 with 100, I'm going to subtract 30, and that answer is 70. So coming down here, I'm going to record 100 is my first term, 70 is my second term. And based on what I see, I think I'm going to keep subtracting 30s. So maybe this next one would be 40. Subtract another 30 would be 10. And then -20. And then one last time, -50. And we can confirm all these 6 term values by using the recursive formula. So now time for n to be 3. Here and here. So now this means I've got to go back and retrieve a2's value. Don't forget the -30 equals. So back and retrieve a2's value, 70 minus 30. And this is 40. There's not a lot of pattern here in seeing this formula with the recursive formula. They're kind of tedious, but it is another way to represent an arithmetic sequence. So A4 would be the previous term minus 30. Go up and grab A3, putting it in here, and writing minus 30. And we'll continue until we get the 6th term. And all our answers confirm with what we thought by inspection. Okay. All right, let's look at E. It also is a recursive formula, and it represents an arithmetic sequence. So we really want to focus on the formula. So I went, oh, that's the previous term to n, and I'm always adding 4. So I know the first term, and I also know the common difference is to add 4. So this part of the recursive formula is important to reveal to us that we're dealing with an arithmetic sequence. Let's see if we can get the answer down here and then go back and do the work. So the first term is -7. I'm going to add 4 and continue to add 4. And I think I need one more. These should be the functional values or the term values if we did show all the work. So coming back up here, a subscript 1 is -7. A2 would be A1 plus 4, but we know A1 is -7 to add to 4. Cleaning that up is -3. Yep, it confirms with what we inspected down here. We're always adding 4. Yep, confirms with this one down here, and I'll just go ahead and finish up to 6 terms. All right. And then hopefully we can extract, from what we did, especially with examples A, B, and C, that this would be a formula that would give us the nth term, any term, even no matter how far into the sequence you are. Okay, this could give us straight up a way to find the nth term of an arithmetic sequence if we know the first term and the common difference. Okay. So in test 4, if you guys want, you guys can write this down on a sheet of paper, this formula. It'd be okay to have that formula written down. There'll be a couple of formulas in sections 8.2 and 8.3 that I'll say to you guys that feel free on a sheet of paper to have those written down so that you have the access to those formulas. We got enough to worry about besides having to memorize formulas. All right, let's look at example 3. It says, find the indicated term of the arithmetic sequence with first term a sub 1 and common difference d. So we want to find the 16th term when the first term is 9 and we keep adding 2's. Now, certainly that one's manageable to do on a calculator. For example, you could do 9 plus, and you could add 2 15 times to get to the 16th term. So why not if there's no work that's, being requested or graded. Okay, but we're going to go ahead and practice the new formula. So to find the 16th term, let's first find the formula. Let's first find a subscript n using the formula. So remember the formula on the other side was a subscript n equals, it's the first term plus parentheses n minus 1 times d. So every time you write it down, at least, it kind of helps you memorize the formula, even though you'll have it on a piece of paper. Still kind of good to have, in your memory. Okay, so let's modify this formula. So a sub n is equal to the first term. I have the first term, it's 9, plus, I don't know what n is yet. Could be any term, and the common difference is 2. So this is times 2. And you can put that in parentheses or not. The suggestion even without parentheses is that you're multiplying it in. So a sub 1 and d. Now I can find the 16th term. So 16 is your n. 16 goes here. It's the first term plus, and this will be 15. Because 16 minus 1 gives us 15 times 2. And then you can go to your calculator. So 15 times 2 I would do, and then I'd add the 9. It looks like it's going to be 39. All right, we're supposed to find the 60th term, given the first term is 8, and we keep adding 6's. Now on your calculator, you could start with 8 and add 59 sixes if you want, but that's going to be kind of tedious. So let's first find a formula with this new given information. So I'm going to write the formula down. Below it, I'm going to keep a sub n. I'm not ready to find a subscript 60. I'm going to put a1 in as 8 plus n minus 1 times 6. Okay, now I'm finding the 60th term. That's your new n. 8 plus, so this is 60. This is 60 minus 1. That's 59. You can write it out that way. Go to your calculator and get an answer. And I previously got 362. All right, example 4 says write a formula for the general term, also the nth term. That's what these are up here. Okay, so write a formula for the nth term of each arithmetic sequence, then use that formula to find the 12th term of the sequence. So same thing we did here. So let's first find a subscript n, the formula. This is called the formula. All right, so what we need first of all is we need to know what the first term is, and we need to know what the common difference is. So they're not going to straight up give it to us. Sometimes we have to extract it. Well, obviously the first term is 6, and then I have to, being told this is an arithmetic sequence, I know they're always adding the same number to get the next term. So from 6 down to go down to 1, I'm going to add a -5. And I'm just double checking, is 1 plus -5 -4? And is -4 plus -5 going to give you the -9? It does. All right, so let's write the formula down. Next step, let's insert A1 and D. I'd go ahead and put -5 in parentheses, otherwise it almost looks like you're subtracting 5. Or the parentheses indicate the multiplication. All right, what term are we finding? We are finding the 12th term. So now time for n to be 12 here and 12 here. If you want to go straight to 11, that's fine. Let's go to your calculator, and I got -49. Same thing with B. They returned to giving us the first term and the common difference instead of giving us the sequence for us to find it. Recording the formula. Still keeping a subscript n, inserting first term and common difference. Going back and finding the 12th term. (11 times 3 plus 6). And I got 39. Okay, this is a recursive formula because you can see in the subscript that you have an n and then an n minus 1. Different than in the formula, this n minus 1 is not part of a subscript to locate a position in a sequence. Okay, so this is though. So studying this recursive formula, I'm going to add to a previous term from n, I'm going to add 5. So it looks like I needed to extract that my common difference was 5. So let's first find the formula. Insert 6 and 5 in the appropriate positions. And what term am I finding? Oh, the 12th term. So 11 times 5 plus 6, 61. Okay, all well and good there. Some more objectives down here. It says the sum of the first n terms of an arithmetic sequence denoted by, they're spelling out what the notation is. Look, that big S represents a sum. That n represents how many terms we're adding. So we want to find the sum of so many terms, n terms. Okay, it's called the nth partial sum, and it can be found without having to add up all those terms. This is actually a formula that we can use to find the sum of a certain number of terms of an arithmetic sequence. Okay, so this is one of the additional formulas that you can write on a sheet of paper and have in front of you when you take test 4. All right, let's study this formula. It says the sum of so many terms n is equal to the number of terms, whatever that is, that number, same as here, divide by 2, times the sum of the first term and that a sub n term. So if I'm adding 12 terms, then I would have s subscript 12. 12 would go here. 12 would go here. 12 right here locates a position, okay, of a term. So I'd have to find the first and the last terms in order to use this formula. So I've got to know a specific term, the last term, in order for me to use this nth partial sum formula. So let's see how that looks. Okay, example 5, it says find the sum of the, so when you see the word sum, that should connect you to this formula right here. Okay, especially when it says arithmetic sequence, because that's what this formula is for. Find the sum of the first 15 terms. Okay, well, n is the number of terms, so that's 15. And then here's the sequence it gives us. So here's term 1, term 2, 3, 4. I see that I keep adding 3s, so that's my common difference. I could keep adding 3s until I get to the 15th term. I could go back and add all these together in my calculator. That'd be fine. But that's not bad when you're only adding like 15 terms. But if you're adding 150 terms, who wants to do that? You'd instead want to use this formula. So let's see what we need to do. Okay, so n is 15 in my example. Okay, this example, 15 here. 15 is here. We're good. I know the first term is 3. 3 plus, well, not 15, but the 15th term that's over here. So I've got to find a subscript 15 first. So let's find a sub n first. That's what we just did previous in example 3 and 4. So a sub n, let's write the formula down. Okay. The first term is 3, and then n minus 1, and then times, with the common difference here, we keep adding 3, is 3. So what term do I need? Well, I need the 15th term. So a subscript 15, 3 plus, this is 15 minus 1, or 14 times 3, and I believe that's 45. That's the 15th term, okay. So this number right here would be 45 if I continued this pattern. So now let's find the sum of all these numbers and everything in between. So I want to find the sum. I'm going to write this formula down. And then below it, I'm going to customize n to be 15. Here too. Inside parentheses, the first term is 3. And the 15th term was 45 that we got from here. Okay. And then I'll go back and do all the work on my calculator. So I'd add these and then multiply by that fraction, and I think I got 360. So if you were to add all of these terms up and everything in between, you get a sum of 360. Okay, and our final 2 examples here. I think things change because I see the sigma notation, so let's see what they want us to do. Use this same formula, S subscript n, use the same formula to evaluate a summation. Well, summation is just a different way to say you're adding the terms of this sequence, which is what we're doing here, adding the terms of that sequence. All right, use that formula to evaluate a summation. Instead of asking for the sum of terms in words, like these words right here, we can use summation notation. Write out the first 3 terms and the last term, then use the formula for the sum of the first n terms of an arithmetic sequence to find the indicated sum. Use that. So, studying the sigma notation, I can see that the index of summation is I, and we start at I equals 1, and we want to go up to the 30th term. And then our formula is 6i minus 11. Okay, so let's write out the first three terms. So if I is 1, 6 minus 11 is -5, plus when I is 2, that's 12 minus 11 or 1, plus when I is 3, that's 6 times 3, 18 minus 11 is 7, plus ... plus the last term is going to be when I is 30. So 6 times 30 is 180. 180 minus 11 is 169. Okay, so they want me to add all these terms together. So I'm going to use S subscript n. So let's see, S subscript n over 2, A sub 1 plus A sub n. Okay, so for my problem right here, how many terms are we adding? Well, it's the upper limit, so that's 30. So 30 goes here. Let's reach inside here. I'm going to add well, let me use the notation. I'm going to add A subscript 1 and A subscript 30. First term and the 30th term. You can simplify that if it's a nice number, and it is. It's 15. A1 was -5, and the last term we would get is 169. So just some calculator work here. The sum of the first 30 terms I got was 2,460. Okay, and one last one. Okay, let's write out the first three terms and the last term. So I is 1, that's 4. Sigma means add. When I is 2, that's going to be 2, plus when I is 3 times -2, -6 plus 6 is 0. So it looks like it is an arithmetic sequence because I'm reducing by 2 every time. Plus ... plus. Now let's jump up to the 40th term. And so -2 times 40 is -80, plus 6 is -74. Okay, now we want to sum all these numbers. I'm going to write the formula down and then customize it with my numbers. So I'm going to add 40 terms. 40 over 2. I need the first term, and I need the n is, what, 40? The 40th term. Remember, this is the 40th term. That's the first, second, third. And additionally, let's insert some more numbers. This is a nice number, so I'm going to go ahead and reduce it to 20. And that's 4 plus -74. Add together, multiply by 20, and I got -1400. All right. So this is some of the work that we do with the arithmetic sequences.